right, number one, we want to consider the following functions. So they have given us f with some ordered pairs, and they've given us g with some ordered pairs. Now this can be done a couple of ways. We can have equations, or we could have express values like we're given here. However, the first thing we want to do is find f plus g of 1. So let me show you what that means. So f plus g of 1. So what that means is we're going to take the f equation and plug in a 1 for the x value and get the y output. And then we're going to do the same thing for the g equation. We're going to plug in a 1 and get the y output. So I'm going to go to f, up here these ordered pairs. When x is 1, the y value that we get is -1. So I'm going to replace this with a -1. So I give you x, you give me y. We're going to do the same thing with g. So in the g equation, the ordered pair 1, the y value is 1. So we're going to replace that with a 1. So f of 1 is -1, g of 1 is 1. When you add those together, you actually subtract because they're different signs, and you get 0. All right, so we're going to do the same thing with subtraction. And so we've already laid out the groundwork. We already know what those numbers are. So part B, f minus g of 1. Okay, so all we're going to be doing is f of 1 minus g of 1. And then f of 1 was -1. And this time we're subtracting, so minus g of 1, which is 1. So it looks like we have a -1 minus 1, and that will give us a -2. All right, this time we're going to be multiplying them together. So f of 1, f times g of 1 is the way we read that. That equals f of 1 and then g of 1 like this, which equals -1 times 1, which is just -1. And then we have f divided by g of 1. So part D, f divided by g of 1. Okay, again, this means f of 1 on top, g of 1 on bottom. So you're just plugging in 1, and then those values are the same. -1 divided by 1, because that's what g of 1 was. And then this gives us a -1 as well. All right, now number 2, we want to find the formula for f plus g of x. And then we're going to simplify our answer, and then we're going to find the domain. Okay. So, for number 2, we're given that f of x equals -5x. And then we're given that g of x is equal to the cube root of x. Okay, and then we want to find f plus g of x. Okay, so all we're going to be doing is adding f and g of x together. So that means, just like it did with the numbers, f of x plus g of x. Okay, well, that is -5x plus g of x is the cube root of x. Now, cube root is different from just plain old x. So there's no simplification that we can do here. This is what f plus g of x is equal to. Now, if you can simplify, but in this case we cannot. Okay. Now, with domain, f plus g, f minus g, and f times g, all domains are the intersection of f and g. Okay, so when you do f plus g, f minus g, f times g, all the domains are going to be the intersection of f and g. So the domain of negative 5x, so I'm going to say domain of f, that is going to be negative infinity to positive infinity. The three things that we have talked about that you check for domain: do you have a fraction with x in the bottom? No, because that will cause us a restriction. If you had a fraction, whatever makes the bottom 0, you have to get rid of it. We don't have that problem. Second, do we have a square root, an even root? No, we don't. So that gets rid of us having to deal with negatives and get rid of those. And then the third is, do we have a logarithm? And we don't. So our domain is the whole number line from negative infinity to positive infinity. And then the domain of g. Okay, so we have this. Do we have any fractions? No. Do we have an even root? So we do have a root. This is a radical, but it has to be even. It has to be like 2, 4, 6, 8, or something like that. This 3 is not going to cause us a problem. In fact, the graph of this looks like this. It just goes out each way. So you can see that that line is going to go all the way to the negative numbers, and the right side is going to cover all the positives, and so you're going to get the whole real number line. So even though it's a radical, it's not an even root. So you got to look for fraction, even root, logarithm. None of those are present here. So again, your domain is negative infinity to positive infinity. Now, if I look at those both as number lines, and I was to lay them on top of each other or see where they match up or where they touch everywhere because they're both the same. So the domain of f is all real, the domain of g is all real, so when they intersect, when they overlap, the domain of f plus g is still going to be all real numbers, or negative infinity to positive infinity. But that's what we mean by intersection. Where do they overlap? What do they share? What do they have in common? And it will be everything. So the function is just negative 5x plus, I need the keypad to do cube root of x, cube root of x, can't simplify that, and then the domain, negative infinity to positive infinity. Okay, and then there's a part 2 here. We're going to do the same thing for f divided by g. Now this is going to be a little bit different because now we have a fraction. So let's talk about that. So same functions, say 2b, we want to do f over g of x, which just means f of x divided by g of x. To put that in parentheses. The f of x was negative 5x. G of x was the cube root of x. Now, with math, we do not like to have roots on the bottom. We don't like it at all. We need to get rid of it. And it does say to simplify. I hadn't played with this new system yet, so I'm not sure how they want you to, if they do want you to simplify it or not, or if they want you to leave it like this. However, I'm going to show you the simplified answer, and then if it takes the input, then great. If it doesn't, then we'll fix it. So we want to get rid of a cube root. Now, usually with a square root, let's just say, for example, so you can kind of get an understanding. There's a pattern or a reason why we're doing this. Usually with a square root, so let's say if I had like a 5 over square root of 2. I'll just use some numbers, for example. To get rid of a square root, you have to square it. You need the same thing times itself. So all you have to do is multiply by square root of 2 on top and bottom. Okay. Reason why, whatever you do to the top, you got to do to the bottom. It's like multiplying by 1. And when you do that, you'll get 5 square root of 2. And on the bottom, you'll get the square root of 2 squared. Okay. And square root, that's understood to be a 2. Square root and square will cancel out. So you need whatever number is here to cancel it out. So when it's a square root, I just need one of those terms. However, this is a cube root, so I need 3 of them because I need 3 of those to get cubed. So I already have 1. So what we need to multiply here is the cube root of x, this whole thing squared, okay? Because 2 plus 1 will give you 3 of them and cause 8 to cancel out. So that's something that you got to kind of pick up on with the pattern. All right, so up here I'm going to be doing the cube root of x squared. All right, and then when I simplify that, I'm going to get a negative 5x, and this is interchangeable. That x can be squared on the inside or on the outside. It'll work the same. So I can say a negative 5x, and I will just say cube root of x squared. Okay, you can put it in or out. It does the same thing. Over, when I do this together, this will give me cube root of x cubed, because I multiplied 1 times 2 of them gave me 3. The cube root and cube will cancel out, okay, and that will give us negative 5x cube root x squared all divided by x. So either the computer wants this input when you simplify it, okay, which is definitely a little bit of a challenge to think through and understand what's going on, or they will allow you to leave it like this, which is not the norm. Okay, we don't like to have radicals on the bottom. So I'm going to assume that they want you to simplify it and put it in this form, and then of course if they don't take it, we'll get a similar example, and I'll just leave it like this. And then let's talk about the domains. So we talked about the domains of f and g on the previous problem. I might have got rid of it. The domain of f, okay, was all real, and also the domain of g was all real. Okay. Now, the difference is when you do the domain of f divided by g, you have to keep that restriction of d, domain of g, cannot be equal to 0. Okay, so whatever makes the bottom 0, we have to remove that number. Okay, so in this case, the number that would make this 0 is 0. So I can't use 0. So if I did a number line, this one would be from negative infinity to positive infinity. This one would be, it would have a little space in there because we have to remove the number 0. So it would go from infinity, negative infinity to positive infinity. So when I match these up, they intersect everywhere except for this 0 point that's missing. Okay, so that means our domain is negative infinity up to 0, and then we have to do union 0 to infinity. We have to remove that point that makes the denominator 0, which in this case would be 0. So I'm going to do the simplified form. Negative 5x is the keypad, cube root x squared, and that is all divided by x. Okay. And then our domain is negative infinity to 0, and then you have to do the union 0 to infinity. Okay, so it says your answer is not in simplest form. You have one more opportunity. So I'm guessing they don't like this simplified form, which again, like I said, this is a different system. And so I'm just going to just change this back. They didn't actually make me do a different answer. I can just type it the way it is. Okay, so they're going to be nice and let us leave it. But just be mindful that that is not 100% correct. Okay. Usually they want you to reduce it. Keypad, cube,